Hello, this is Stuart Lloyd, and this video is about significant figures. It will tell you when a figure is significant or not significant, and it will also tell you how many significant figures you are supposed to give an answer to in an exam question and why. So first of all, we will go through when a figure in a number is significant or not significant. So you have a number, you need to know how many significant figures it has. So first rule is, if the number is not 0, it is a significant figure. So for example, 123 has 3 significant figures. The 1, the 2 and the 3 are significant. Rule 2. If you have a 0 between two non-zero figures, that is significant. So for example, in 2018, the 2 is significant because it's not 0. The 1 is significant because it's not 0, the 8 is significant because it's not 0, and this 0 is also significant this time because it is between the 2 and the 1. So this is 4 significant figures. Right, rule 3. If you have a decimal point, all zeros to the right of decimal point are significant. So for example, in 1.01, that has 3 significant figures, the 1, the 0 and the 1. The 0 is significant here for 2 reasons. It is to the right of a decimal point and it is between 2 non-zero numbers. So here's another example. 1.00 also has 3 significant figures. Even though these are zeros and they're not between 2 non-zero numbers, they are still significant because they are to the right of a decimal point. And we will explain later why 1.00 is different to just writing 1. Number 4, if there are any zeros to the right of the last non-zero figure and there's no decimal place, then they're not significant. So for example, 1,000 here has 1 significant figure. This 1 is significant. These 3 zeros are not significant because there's no decimal place and there's no other non-zero number. But if I put a 0.0 at the end, then all these zeros become significant. So 1000.0 now has 5 significant figures. This 1 is significant and these other 4 zeros are now all significant. Okay, just another example, 2300 has 2 significant figures, the 2 and the 3. Okay, you might see, probably not in GCSE, but you might see something like 2300 with a decimal point. That means the zeros are now significant, even though there's no number after the decimal point. And then lastly, all zeros before the first non-zero figure are not significant. So 0.00023 has 2 significant figures, the 2 and the 3 again. So these 4 zeros are not significant. I know there are 3 zeros after the decimal place, but there needs to be a non-zero number first for those to be significant. Okay. And if I were to write 123 as 0000000000123, it's still only got 3 significant figures, the 1, 2 and the 3. Because you don't need to write these zeros really. This is like saying it's got no thousands, no 10,000s, etc. Well, if you write 123, then you're implying that without having to write the zeros. So those zeros are not significant, they're not needed at all. So why are they important for science? Well, a significant figure tells us about the resolution of the measuring instruments we use. So the resolution is the number of decimal places that an instrument can measure to. So for example, this voltmeter can't really measure to any decimal places. It can only measure to whole numbers because you can see it goes from 0 to 5 and then the lines in between are 1, 2, 3, 4. So the resolution of that is just to whole numbers, it's to 0 decimal places. Okay. If I had a voltmeter that can measure 1/10 of a volt, that would be much better because then I could measure whether a number would be 1.1, 1.2, 1.3 rather than just 1. Okay. So this goes on to why is writing 1.0 different to writing just 1? Well, it all comes to this thing about rounding. So if you say something is 1 meter tall without any decimal places, then you're saying you're measuring it to the nearest meter. So you're saying the thing you measured it with can only tell you in whole numbers of meters the closest meter it is, which means that could mean it's half a meter tall, because 0.5, if you have to round 0.5 to the nearest meter, that means that would be 1 meter. It also means it could be 1.4999999 meters, which basically rounds up to 1.5 meters. So if it's less than 1.5 meters tall, then that also rounds down to 1 meter. Which means if you have a measuring instrument that can only measure to whole meters, you are saying that something could be between half a meter or 1.5 meters tall when you say it's a meter tall. Okay, which is a massive range, and it's not the kind of range we want in science for our resolution. So we want as small a resolution as possible, because that's a huge range and there's loads of room for error. So say you had something that could measure tenths of meters. If you could say something is 1.0 meters tall, okay, then you know what it is to the nearest tenth of a meter, which means if something is 1.0 meters, the smallest amount it could be is 0.95 meters tall, okay, because that's the smallest number that will round up to 1.0, and the biggest number that it could be is 1.05 meters tall. So instead of having a whole range of a meter, you have cut it down to a tenth of that size, to a tenth of a meter. So that's a much more, the resolution of that measuring instrument is much smaller, so it's going to be able to give you a better idea of how tall something is. Okay, so that's why significant figures are important. It's about resolution. Okay, so here's just an example here. So say you had a ruler that you knew was a meter long, but it didn't have any other markings on it. So you could only tell whether it was a meter, or you could tell whether it was closer to 1 meter than it was to 0 meters, but that's about it. So if you took these objects here, so this garden gnome is exactly a meter tall, so there's no problem here, we say it's 1 meter. This lamp, looking at it, we know you can see it's less than half a meter tall, it's closer to 0 meters, but it's obviously got some height. But the thing is, our meter ruler can't tell you its exact height, they can only tell you whether it's 1 meter or not 1 meter. So according to this meter ruler, the lamp is 0 meters tall, which is a really silly measurement, because you can obviously see it's a certain height, but you can't measure its actual height with this ruler. And this dog here is obviously less than a meter tall, but since we can't tell exactly how much it is, since it's closer to 1 meter than it is to 0 meters, we have to say that the dog is 1 meter tall. So according to this ruler here, this dog and this gnome are the same height, and this lamp has no height. Okay, so that's so this is a very poor resolution, and this is measuring the height to one significant figure. Well, say we then got a ruler that can measure tenths of a meter, so it's a meter long and it can measure tenths of a meter. So now we can give the value to two significant figures. So this gnome is exactly a meter tall. So since we can measure it to two significant figures though, we don't say it's 1 meter tall, we say it's 1.0 meters tall. So we can easily tell that this gnome is not 1.1 or 0.9 meters tall, it's exactly 1 meter. We can now measure this lamp. We don't know its exact height, but we know that it takes up 1, 2, 3, 4 tenths of the ruler. It's a bit taller, but it's not so tall it's closer to the fifth one. So we can say that this lamp is 0.4 meters tall now. Okay, so we know that it has a certain height. And now this dog, 1, 2, 3, 4, 5, 6, 7, 8, is 0.8 meters tall. So it's just a bit lower than that. So to two significant figures, it's not perfect, but it's obviously better than measuring it to one significant figure, where you can only ever tell if it's 0 or 1 meters. Right, let's move on to significant figures in science calculations. So, sometimes you will be asked to give a number from a calculation to an appropriate number of significant figures. How do you work that out? Well, the number of significant figures you should use is equal to the number of significant figures that the number in the question that has the lowest number of significant figures So for example, looking at this, if you're given 0.12 amps, 0.234 amps and 0.117 amps as a question, and you have to calculate the mean, so you add them all up, 0.12, 0.234, 0.117, you divide those numbers by 3, the answer is 0.157 amps. That is not the answer. You go to your question, so that is to two significant figures, that's to 3, that's to 3. So yes, so the mean current has to be to two significant figures, because out of the 3 numbers you were given, the lowest number of significant figures is 2. So when you have to give an answer to an appropriate number of significant figures, you look at all the numbers you're given and you find the one with the lowest number of significant figures and use that one. So the answer is actually not 0.157, the answer is actually 0.16. So why is that? Why can't you just do 0.157? Well, we'll do an example which goes back to the meter sticks. So say you had these 3 figures to measure the height of. So this boy is almost a meter tall, so according to our meter sticks that's 1 meter tall. This ape is taller than a meter but not close enough to be 2 meters, so according to our meter sticks that's 1 meter tall. And then this Viking is 2 and a bit meters tall, and the extra bit is almost 3 meters. So according to our meter sticks, this Viking is 3 meters tall. So we have 1, 1 and 3. So if we calculate the mean of those, we do 1 plus 3, divide that by 3, we'll get 1.66666, 1.6 recurring, okay? So the answer is 2 significant figures. So imagine we took something that's to 1.6 recurring meters tall, like Imhotep, and then we measured them with our meter stick, okay? So if we measure Imhotep with our meter stick, he's 1.6 meters tall. But our meter stick can't tell that he's 1.6 meters tall. Our meter sticks can only tell that he's taller than a meter and he is closer to 2 meters than he is to 1 meter. So according to our meter sticks, we have to say that Imhotep is 2 meters tall, which is why we can only give the answer to 1 significant figure. Because the measuring instrument, if we were to use the measuring instrument that we used to calculate these figures, to calculate something that is the average height of these figures, we can only say that it's 2 meters tall. We can only use it to the same number of significant figures. Okay. Say we had a meter stick that goes up to, we can measure 1/10 of a meter then. So this boy is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 9/10 of a meter tall, or 0.9 meters tall. The ape is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and a bit, but not quite tall enough. So that's 1.3 meters tall. And then the Viking is 2.7 meters tall. Right, so now we've got the answers to 2 significant figures. If we do a mean to 2 significant figures, so we do 0.9 plus 1.3 plus 2.7, divide all that by 3, we get 1.63 recurring. So if Imhotep is 1.63 meters tall, we measure Imhotep with our 1/10 of a meter sticks. We can't actually tell that Imhotep is 1.63 meters tall, but we can tell that Imhotep is 1.6 meters tall. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we can see that he's 16/10 of a meter, or 1.6 meters tall. We can't measure accurately this 0.03 recurring. So the reason we use the same number of significant figures as we're given is because the significant figures we're given is because of the measuring instrument we used. And if we use the same measuring instrument to work out the mean, something that's the mean measurement, then what will happen is we can't measure any closer than the same number of significant figures. So that's why we have to give our answer to the same number of significant figures as the number with the least number of significant figures in the question. Okay, so here's just an example here. Titrations are in chemistry, so you have to work out how much acid you need to neutralize an alkali. You use a burette. You go on until you get titrations that are concordant, as in titrations are almost the same, or to within 0.1 or 0.05 centimeters cubed. So if you did 4 titrations and it took 25.5 centimeters cubed, 25.2, 25.4 and 25.4 to neutralize the acid, you'd add them all up, you divide by 4, you'd get a mean of 25.375. But since you are measuring them to 3 significant figures, you have to give the answer to 3 significant figures, so the answer is actually 25.4 centimeters cubed. So that is almost the end, but sometimes in the question you might not be asked for an appropriate number of significant figures for an answer. You might just be told that you have to give the answer to a certain number of significant figures, like 3 significant figures or 2 significant figures. So you should keep an eye out for how many significant figures a question asks for, or if it mentions that you have to give it to a certain number of significant figures. And the reason is, if it tells you that, it will be because there is at least 1 mark, or usually 1 mark, for the number of significant figures. So if you gave the correct answer but to the wrong number of significant figures, you would get 1 mark less than whatever marks the exam question is worth. Okay, so I hope that's been helpful. So significant figures are a problem in exams. A lot of people fail on them. So hopefully after watching this video, you won't get it wrong then. Okay, have a good time. Bye-bye.